Okay, so next we have Igor Korsakov. He's going to tell us about typical vulnerabilities in Lightning apps. Welcome.
Thanks, Igor.
Hello, Berlin. How you guys doing tonight? All right. Okay, so let's start. My name is Igor. I'm the creator of Blue Wallet. We added Lab Marketplace pretty early. I think it was January this year, and it feels like a lifetime ago. So I've seen a lot of vulnerabilities in those labs we listed. And basically every second new lab someone sends me is some kind of vulnerable. So like, I'm not even excited anymore about finding vulnerabilities. Because at first I was like, yeah, it's vulnerable. I can hack it. I can extract some satoshis out of it. But now I'm like, okay, it's vulnerable. Maybe I'll report it in a week, maybe, if I won't forget. So I decided to give this talk for developers hoping that they will write more secure labs with better user experience. They won't lose money on them. They won't get wrecked. So let's start. We don't have much time. So there are 4 typical Lightning apps vulnerabilities that I've discovered, like top 4. 2 of them are Lightning Network specific. 2 of them are general web app vulnerabilities. And when I say Lightning Network specific, I don't mean that protocol is vulnerable. What I mean is that general lack of understanding how Lightning protocol works by developers makes them make bad decisions, which makes them write bad code, which is vulnerable. So let's get started. First, what is lab? Lab is a piece of software that works with Lightning Network, interacts with Lightning Network. But usually when you say lab, Lightning app, you mean a web page that can receive payments, that can send payments, and that can require signature from a user. This is basically authentication. This is rarely used, but I hope it will be used more. And in this talk, we'll be mostly covering withdrawal functionality. Withdrawal functionality is not rare. It's like gambling apps, like exchange apps, like some app that can send you money. There are probably ways to trick it to send you more money than you're actually allowed to get. And this is basically hacking, extracting more money than you're allowed to. First attack, I like to call it hold invoice attack. To better understand it, let's refresh in our memory how send payment works in Lightning Network. So imagine Charlie wants to get paid by Alice. So what he does, he creates a pre-image, he hashes it, and this hash is a puzzle. So he adds metadata like expiry time, like text description, the amount, routing hints. He signs this, and he gives it to Alice. Now, Alice wants to pay this invoice. What Alice does, she creates channel state update to Bob, who is the routing node in this example. And Alice protects this channel state update with this puzzle. And Alice promises to Bob that Charlie has a solution to this puzzle. And if Bob will make the same channel state update to Charlie, Charlie will release a pre-image, and the payment will be finalized. So both channel state updates will be finalized, and that's it. Payment is done. The bottom line is, if you're Charlie, life is good for you. You either see the incoming payment, either you don't. You either accept it, either you don't. Well, you're always in determined state. If you're Alice, life is not as good for you. Because once you've made the first channel state update, you don't know what's happening anymore. If it's stuck, like, you have no idea. You can't cancel the payment. You can't redo the payment, because if you send the payment again and it will go through, and both payments will go through, you're essentially paying for the same thing twice, and that's losing money. So yeah, life is not good for you if you're Alice. And a lot of labs are not prepared for this scenario. Like, if the withdrawal payment is stuck, lab is not prepared. So if it's stuck, and if you can, sometimes you can send another withdrawal, and the total amount is greater than you are allowed to withdraw, this is essentially hacking the lab and making more money than you're allowed to withdraw. Let's take a look at the code example which handles withdrawals. So this is theoretical code. There are several issues with this code, but we'll be focusing only on hold invoice attack in this example. So imagine there is a handler function that handles withdrawal requests from a web app, for a web app, and we have a balance check. If balance check is okay, we do the send payment through Lightning. And if it goes okay, there is a callback function that reduces user's balance. Now, if the payment is stuck, and this lab is totally not prepared for that, if the payment is stuck, the attacker could request another withdrawal, and it will be stuck again. It's actually stuck on the callback function of before we reduce user's balance. So someone could issue several withdrawals, and they both get stuck. Then they get unstuck magically. They go through, and oops, you've got negative balance because several callbacks actually fired and reduced user's balance, and it became negative. This is real-life screenshot from tip.me from the time it was still vulnerable. So someone pulled this off actually, maybe by accident, and he withdrew more than he was allowed to. To make things even more interesting, Lightning Labs released a cool feature which is called Hold Invoice. And this acts as a regular invoice, except when Charlie, if he should hold invoice. Once he sees the incoming channel state update, he's not releasing the pre-image automatically. He's waiting for node operator's input, whether to accept invoice and release the pre-image, whether to cancel it completely. So this is a tool to make stuck payments 100% of the time, like all the time. And you can take this tool and feed it to some lab and see if it's prepared to actually handle stuck payments. So this is a way to execute this attack. First, you compile LNZ with the support of hold invoices. Then there's a handy script, invoices.sh, which creates the hold invoice, creates pre-image, creates hash, then writes a settle invoice string to settle.sh. This is a handy script we're going to use later to claim incoming channel state updates. And then we add hold invoice and print it in console, and we can take this invoice and feed it to some lab that allows withdrawals. Now, if you're lucky, you'll see this. You check your list channels, and if you see several pending HTLCs incoming, this is like several incoming transactions to you. You can claim them both with settle.sh script, and boom, you've got more satoshis than you're allowed to withdraw. How do you protect against that? Well, you should atomically look out full withdrawal amount. Before doing anything else. And this lock should not auto-expire. As a developer, I know it's handy to make atomic locks auto-expire, but don't do this because it's really tricky to get this auto-expire timeout right. It's related to CSV delta, and it requires more investigation. And there's no right amount for now. It's not 5 minutes, it's not 1 hour, it's not tied to invoice expiry, because invoice expiry time in reality is just a meaningless number. So what I usually do, I wait more than 24 hours, and if it's, and I check list payments during this period. If it's not there, if the withdrawal is not there, then in 24 hours it's safe to lift the lock. If it's there, then you lift the lock and reduce user's balance, and disregard invoice expiry. Next attack, stealing free fees. I know that you all heard that Lightning payments are instantaneous, it's almost free, so yeah, if I'm writing a lab, I want to offer my users free withdrawals. But if you do this, actually someone could set up a routing node with pretty high fees, and always withdraw through this node, and this node will automatically claim all the fees, stealing all the fees. And then the fee limit here won't help. So there's no difference between 1% fee limit, 10% fee limit. Once this automated, hacker will drain your balance dry from your channel. How do you protect? You don't give away free fees. Well, the way I do it is I lock away user's balance, the withdrawal amount plus fee limit. So if user wants to withdraw 100 satoshis and the fee limit is 1%, I lock out 101 satoshis. And this 1 satoshi will go towards fee, if any fees. You might be a little bit smarter than I am, so you can calculate the actual route's fees and ask user whether he's willing to pay this exact route with these exact fees. Theoretically, this is how we would do this. So in this example, we're querying route to a destination with a specific amount and sending a payment with a fake payment hash. So no one has a solution to this payment hash. And if it will bounce back with the payment hash error, this means that the payment actually went through this specific route and bounced back because destination does not know the solution to the hash. This means you can take fees from this route and ask user whether he's willing to pay those fees. And then, if he's agreed, then you pay this specific route. Next, this is my favorite attack. Actually, it's really it's really common. It's really simple to make this mistake. Uh, in fact, you can go back home and try your internet banking or try your favorite e-commerce. It might be vulnerable. I really like a story when some dude hacked Starbucks website for infinite gift cards. Oh yeah, that was pretty sick. And he actually responsibly disclosed this attack to Starbucks, and they almost sued him. Yeah, but it turned out well for him. Well, the same code that handles this, handles withdrawals, we check user balance, blah, blah, blah. The bottom line is, this is probably handled by a web server, and the chances are it's handled by a multi-threaded web server. So with a little bit of luck, someone could request several withdrawals at the exact same time, and this executed is at the exact same time, so the user balance check goes at the exact same time, and it passes, and the execution reaches the send payment stage, and several withdrawals are executed, and boom, you're hacked again. What do? You set the atomic lock, and if you couldn't obtain the atomic lock, you should throw an error. Next, this is a stupid mistake. I'm sure you guys not that stupid to make this mistake, but what usually happens is you have all the checks in place that the amounts are positive all the time, but then you refactor something, you rearrange a little bit of code, and you omit this check, and you're suddenly vulnerable. I know only one solution to this is that you write tests. So if you have acceptance tests, if you have integration tests, please include a test case for negative amounts, and this way you'll know if you introduce regression to your code that something went wrong and you should go back and fix it. This concludes our 4 typical vulnerabilities, my personal top 4 vulnerabilities for labs. But just to make this talk a little bit more complete, let's go through other attack vectors with Lightning Network. I remind you that zero-amount invoices are still unsafe, so someone could steal the whole amount, almost the whole amount. This is how it works. So imagine you're paying zero-amount invoice, and the routing node can make a guess that this is a zero-amount invoice payment. So instead of routing the full amount, routing node will send to destination only 1 Satoshi. Destination node will release the pre-image because destination node does not know the real amount. And this pre-image will finalize the payment across the route, and boom, the routing node stole the majority of the payment, the most of the payment. There are no evidences that someone pulled this off on mainnet, actually, but I saw developers joking on chats like, oh, this is just a fee maximization algorithm. You get it? Fee maximization algorithm. So someone could pull this off, like, be prepared. Of course, you all know about unsafely open channels. It was patched in major implementations of Lightning Network nodes, so let's skip that. Next, someone could issue old state transaction and DDoS you. And the curious thing here is that DDoS is not that expensive. Like last time I checked, it was $70 per day to rent a botnet that's capable to bring down pretty good server. So it comes down to a basic math, whether it's profitable to rent a botnet and the channel value is higher than this. Yeah, basic math. Next, someone could observe the offline-online patterns of the remote node and choose the best timing to issue all-state transaction. Actually, big hubs or hubs serving mobile users are in perfect position to pull this because mobile users tend to go online, offline all the time. Sometimes they go offline for a prolonged period of time, like going to a vacation, losing their phones. I know watchtowers are supposed to fix this, but I'm not 100% convinced yet. We heard the talk yesterday by Patrick that watchtowers brings a whole new set of complexities, and I'm sure there are other attack vectors for watchtowers. So let's keep our hands on the pulse all the time. And as a final thought, if you're not vulnerable to those 4 vulnerabilities, this doesn't mean that you're on the safe side. There are other vulnerabilities like XXX, injections, blah, blah, blah. So be prepared. And as Lightning Network economy grows, I assure you, black hats will come, tooling will be made, exploits will be written, every possible hole will be tested and penetrated. So if you're thinking you're safe, you're not safe. Even worse times are coming. Because Lightning Network economy grows, and the incentive for black hats will rise. It will be bigger. So we're not on the safe side yet. And as a final thought, the best practices, if you've never written any fintech code, like don't store user balance as a single variable. Always calculate user's balance as a sum of all transactions. Don't store amounts as floats, only as ints. And really, signed ints are okay. Don't try to force unsigned ints everywhere. We have enough bits, really. And relational databases and transactions are a nice thing to have. There's a reason they're the gold standard in payments industry, in fintech, in enterprise. If you'll use them, you'll thank yourself later. And always log everything and keep all logs and do regular accounting, like daily probably, maybe more often. This way, if you'll see some difference between what you actually have and what you're expected to have, then you should go back to your logs and check what happened, what went wrong, where did I lose money? And don't be obsessed with MVPs. I know a lot of labs are written by web developers. They have an MVP mantra, fail fast mantra. This doesn't work here. This is just a way to get wrecked if you're writing very, very fast, like not secure code. And I would like to say thanks to Justin from Bitrefill, to Andre from Zigzag, and great guys from Iron Radar Tech. This talk wouldn't be possible without those guys, so thank you guys. And I'm done. Thanks for listening. You can shoot me an email if you have any questions, or if you have time, you can ask me now. Do we have any time? Cool, we've got 4 minutes for questions. Thanks, guys. No questions? Come on, anyone's got questions?
Yeah, I hate to bring up the E word, but some of these bugs, especially the sequencing of checking your balance and sending money, reminds me of a certain coin with smart contracts. So you may want to look at some of the incidents of how the DAO blew up and what kind of mistakes they made, because you may make the same mistakes with these dApps.
Yeah, I'll probably look into this. Or this was a question.
Yeah, that was my suggestion. Like, look at this. Yeah, look at the similarities.
Okay.
Unless you remember one you want to bring up.
Thanks for the talk. It was great. I was just wondering, the Blue Wallet server-side implementation, I know that you can spin up your own and connect your Blue Wallet to it.
Yes.
Are you thinking of some ways to kind of have like a federation that maybe connects with channels to each other so that there's like a Blue Wallet independent server, like kind of web of hubs or something?
Yeah, I had this thought, but I hadn't had any time to work on this. Yeah, I was thinking that maybe people will spin up their own L&D hubs, and then in the end it will interact with each other and open channels with each other automatically. But I haven't seen too much demand on this.
Yeah, because like we were talking about yesterday, I think this could also help with the multi-sig implementation for the on-chain wallet as well, because maybe the independent like federated servers could like exchange PSBTs with each other, as well as also like automatically open channels and prefer to open channels with other Blue Wallet nodes. I think it would be interesting.
Yeah, that would be cool. But I don't have time for this right now.
Yeah.
Maybe there will be demand for this, and I'll make this.
Okay, thank you.
All right, thank
Thank
you,
you.
Igor. That was great.
Thanks, man.